Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. Welcome now to question 10A, CSEC Math Exam January 2012 video solution. And in this question we are given the diagram of a regular hexagon. We are told it's a regular hexagon and OA on this hexagon is 5 centimeters. O is the center of this hexagon. Now, because it's a regular hexagon, it means that all 6 sides of this hexagon are equal in length and all internal angles are also equal. And what it also means is that lines from the center to the vertices will form 6 equal or 6 congruent triangles, and I have inserted this angle theta, which we will be required to calculate. So if this angle is theta, then this angle also is theta, this angle is theta, this one is theta, this angle is theta, and this angle is theta. So there are 6 of these angles around the center, and each of these lines, O to the vertices, O to A is 5 centimeters, O to B will also be 5, here will be 5, this piece will be 5, this one is 5, and that one also is 5 centimeters. So we really have 6 congruent triangles. So let's put that information in one at a time, information that we need to solve this question. Now, because it's an hexagon, it means that it has 6 sides and 6 internal angles, as I have said. And because it is a regular hexagon, regular means that all the sides are equal and all the internal angles are equal. And the angles will be equal as I've just explained. Now, the first question is asking us to determine angle AOB. Angle AOB, that's this angle that I have marked theta. Now, around the center, we can make a circle that will have a total of 360 degrees, and there will be 6 of these theta angles inside that 360 degrees. So let me go ahead and show that. There it is. We can form a circle around the center, and the total angle in that circle is 360 degrees, but then there are 6 equal angles inside here, and each one will be equal to theta. And so if we divide the 360 by 6, we would have calculated the angle AOB, which we have marked as theta. So let's show that calculation. And there it is. The angle theta is 360 degrees divided by 6, because there are 6 equal angles in that circle, and each of those angles therefore would be 60 degrees. And that's the answer for part 1. Now part 2 is asking for the area of the hexagon, and based on this diagram there are 6 equal triangles in here, 6 congruent triangles, and so if we find the area of this triangle and multiply it by 6, we would have calculated the area of the hexagon. Remember that because this side is 5 centimeters, it means also that this side is 5 centimeters. So in this triangle here, what we would have is 2 known sides and a known included angle, a known angle between those 2 sides. And let's go ahead and show what we would use to calculate the area of this triangle, then multiply that area by 6 to get the area of the hexagon. And this is it. The area of the hexagon would be 6 multiplied by the area of triangle AOB. And as I have said, the length OB would also be 5 centimeters, and we end up having a triangle with 2 known sides and an included angle. And we can therefore use the trig formula for the area of a triangle when there's two sides and an included angle, and it is shown here. When we have a triangle with two known sides and a known included angle, a known angle between the two known sides, the area of the triangle is given by this formula: half the product of the two sides multiplied by the sine of the angle between the two sides. And that's what we're going to be using to calculate the area of this triangle, and we can show that calculation. So the area of the hexagon is going to be 6 multiplied by the area of triangle AOB, which is half 5 multiplied by 5, that's the two sides, 5 multiplied by 5, times the sine of the angle between those two known sides, which is 60 degrees. And when we do that calculation, the result is approximately 65 centimeters squared, because the question did say we were to calculate to the nearest whole number the area of the hexagon, and that's it, 65 centimeters squared. That's the answer for part A of question 10. Let's now move down to part B. Now part B gives us this diagram and speaks of a vertical pole PL on horizontal plane KLM. Okay, it tells us that the angle of elevation of P from K is 28 degrees. It tells us that KL, which is here, is 15 meters. LM, which is here, is 19 meters. And angle KLM is 115 degrees. Now what we must recognize here is that we have a three-dimensional situation. We have two triangles that are in the vertical plane, this one and this one. So these two triangles, this one and this one, they are in the vertical plane, and this triangle is on horizontal plane, right? So we have a three-dimensional situation. This line is vertical, but this line KL is horizontal. Again, this line is vertical and this is horizontal, and the angle between vertical and horizontal is 90 degrees. It does not look like 90 degrees on the diagram, but this is because this is a three-dimensional diagram, and we must be able to appreciate that the angle between vertical and horizontal is 90 degrees. Therefore, this is a right-angled triangle, and this also is a right-angled triangle. So the angle here is 90 degrees, and the angle here is also 90 degrees. Now for the angle of elevation, P from K, angle of elevation is the angle formed by the line of sight when looking upwards. Okay, so it is the angle above the horizontal plane looking upwards. So from K to P, if we were on the horizontal, this is horizontal from K to P, right, to the base of the line PL. So this is horizontal. So the angle above this horizontal up to the line of sight from K to P would be the angle of elevation. So it means that this angle here is going to be the 28 degrees. And later on in the question, we'll be asked for the angle of elevation of P from M. And similarly, that's going to be this angle here, the angle above this horizontal from M to P. So it would be this angle here, angle looking upwards from the horizontal. And that angle, we're going to mark it as theta, so we can calculate that angle later on in the question. So let's mark the angle of elevation of P from M as theta degrees. Now let's go to the questions. The first question is asking us to copy the diagram and show all the angles and the distances in the question, right? So let's go and do that. So let's focus on this section where we will complete the diagram and put the information in. Now, as I said, the angle between vertical and horizontal is 90 degrees. So we can go ahead and put our 90-degree angle here and a 90-degree angle here. Alright, so that's the first thing we want to do. Then we are told that the angle of elevation of P from K is 28 degrees. And I've explained that that 28 degrees is the angle between this line and this line, because this is horizontal, right, from K to the plane containing PL, and so the angle here is 28 degrees, and this triangle is in the vertical plane. That's a vertical triangle. So that's our 28 degrees. And then we can mark the distance of 15 meters. That's KL is 15 meters. So we can put that on the diagram. KL 15 meters. That's this length here. And then LM, which is this one, is 19 meters. 19 meters. So let's show that on the diagram as well. And then we're given the angle 115 degrees. That's already on the diagram. And we're going to place our angle theta, the angle of elevation of P from M. Angle of elevation of P from M. We said we're going to mark that angle as theta. And that angle is theta. Now that's the diagram, and that would be our answer. Now what I want to do is show you the isolation of the three triangles that we'll be working in. Now I'm going to color code the triangles so we can see that there are three different triangles that we have to work in. There are two right angled triangles in the vertical plane, this one and this one. So let's go ahead and color code those. So this first one, we'll give it the color yellow. This one, we'll make it slightly gray. That's a vertical triangle, and that's a vertical triangle. And then this horizontal triangle, this triangle on the horizontal plane, which is not a right angle triangle, we will give it a blue color. So there it is. And then what we can do is isolate this right angle triangle and show it as a right angle triangle. And then we can isolate this right angle triangle and show that one also as a right angle triangle. Alright, so let's take those two triangles out. And that's our right angle triangle from here. Right, that's triangle PLK with the dimensions taken out into this right angle triangle. And then we can isolate this triangle again on this side. So if we take that triangle out, and that's it. So this is the right angle triangle MLP from here. And then we leave this blue horizontal triangle on the diagram. Alright, so part 2 is asking us to calculate, given our answers to two significant figures, the measure of PL, KM, and the angle of elevation of P from M. Now, if we want to calculate PL, which is this, it is better to work on this triangle, because this triangle we have more information than on this triangle. In this triangle we have an angle and we have a side, and it's a right angled triangle. And therefore we can use one of the trig ratios to calculate this side. So let's focus now on this right angled triangle PLK for part 2. Right, so part 2, the first part of part 2 is asking us to calculate PL, and in this triangle we want to find the side that is opposite to this angle in this right angle triangle, and we know this side that is adjacent to this angle. And the trig ratio that connects the opposite and the adjacent in a right angle triangle is the tangent trig ratio. So we can use the fact that the tan of 28 degrees will be equal to this side PL divided by this known side, which is 15, and hence deduce the length of PL. So let's show that calculation. And there it is. So the tan of this angle, which is 28 degrees, will be equal to the opposite to the angle divided by the adjacent to the angle. So that's opposite, which is PL, divided by adjacent. So we can put PL in as the unknown side, divided by 15. And then if we multiply both sides by 15, we'll eliminate this 15 here, and PL will become the subject. Or we can say we multiply the 15 across here and leave PL as a subject. So let's show that calculation of PL. So PL will be 15 multiplied by the tan of 28 degrees. And when we do that calculation, it comes out that PL is 8.0 meters. The two significant figures, that's 8.0 meters. So PL is 8.0 meters. Now, the second part is asking us for MK, this length here. Right? So to calculate this length, we have to come now and work on this horizontal triangle. Now in this horizontal triangle, what we have is a triangle that is not a right angle triangle. Therefore, we cannot use the trig ratios and we cannot use Pythagoras' theorem. What we have to use is the sine rule or the cosine rule to calculate distances and angles in this non-right angled triangle. And in this triangle, what we have is typical case for the use of the cosine rule because we have two known sides and a known included angle, a known angle between them. We have two known sides, 19 and 15, and a known angle between them. And therefore, we can use the cosine rule to calculate the length mk. So let's show that calculation. So for mk, using the cosine rule, mk squared will be equal to 19 squared plus 15 squared minus 2 times 19 times 15 multiplied by the cosine of the angle between the sides, which is 115 degrees. This is the application of the cosine rule. Alright, and then what we can do is calculate this figure and show that mk squared is equal to 826.9, and then we can take the square root of both sides to find mk, and that works out to be mk equals the square root of 826.9, which is equal to 29 meters. That's the two significant figures, 29 meters. Alright, and then now let's look at the third part of this question. The third part is asking us to calculate angle theta, which is the angle of elevation of P from M. So that's this angle here, theta in this diagram. Now remember that we calculated from the first part the length PL, and we calculated that length as 8.0 meters. So we can show that length on the side PL. Right? So we can bring that in and put it there. And so we know in this triangle now, we are trying to find this angle theta. And to this angle theta, we know the opposite side to theta and we know the adjacent. So it's opposite and adjacent in a right angle triangle. And so we must use a tan trig ratio. Tan of theta equals the opposite over the adjacent. And we can use that trig ratio to calculate the angle theta. And let's show that calculation. So tan theta was the opposite side over the adjacent side to theta, and that's 8.0 meters divided by 19 meters. So tan theta equals 8.0 divided by 19. And we can go ahead and show the calculation of theta. So theta would be tan to the minus 1 of 0.421, which is what 8 divided by 19 would work out to be. So theta is tan to the minus 1 of 0.421. And if we do this calculation with our calculator, we see that theta is 23 degrees, correct to two significant figures. So the angle of elevation of P from M is 23 degrees. And that's the solution for this question. And we will look to do question 11 in our next video. Okay, bye. You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.